First people arriving in our online webinar, welcome. Today we will talk about Quarkus and messaging. And this is presented to you by ConSol. We are a consulting company. Right now, our focus is the field of cloud, agile software development and consulting. Here we are, people presenting it to you are Isabel from the marketing, Marco is our speaker, and Marion from IBM, from the part of the hybrid cloud team. And now I will hand over to Marion.
Hi, welcome everyone. Good morning, good evening, good afternoon, and I'm really happy I can be here to join my dear friends from colleague, my dear tech friends, and I brought some slides to show you a little bit who am I and what are we doing and why am I actually here. So I'm sharing my screen right now. Let me show you. So. Again, my name is Marion. I'm part of the hybrid cloud build team and the developer advocacy team here in the region, Germany, Austria, and Switzerland. And usually we are doing developer advocacy all around those regions. And our activities are based on three very important pillars for us: code, content, and community. And with respect to code, you can find a lot of code snippets, walkthroughs, tutorials on our website, developer.ibm.com. And I'm going to share this link in the chat just in a couple of seconds. And our developer advocacies go out to events on conferences, on tech talks, and share the knowledge about hybrid cloud and data and AI topics with you. And on our Quarkus channel, for example, we just had 200 events last year. So if you haven't had the chance to join our community, you are highly welcome to do so. And this is actually the reason why I'm here, because, oh, I'm sorry. We are doing two major activities, right? The first one is our community activities where we share knowledge all around the topics I just said. And the second one is we are also joining up with partners like our friends at ConSol and doing joint workshops and joint build engagements with partners like you in order to, progress your digital transformation. So if you are up for a build engagement and you have something you want to, for example, infuse your processes with AI, or learn more about Kubernetes, OpenShift, or just like reactive programming, like the stuff Marco is going to tell you about just in a second, then please contact me on LinkedIn. You can find me. I'm going to share my LinkedIn profile in the chat just in a second. You're welcome to reach out for me. I'm really happy if we can team up for some amazing activities, because that's why we are here. We want to support our partners in modernizing and infusing their applications with AI. So enough talking from my side. Marco, jump right into the session, and here we go.
Thank you, Marion. So if you give me the screen, I can share my slides. Awesome. So we are going to talk about Quarkus and messaging today. Before we start, I'd like to introduce myself. Who am I? Since I know that this is a boring part of the talk, you will get a little poll. You can answer during while I'm talking about myself, and we will have a look at the poll on the end of the slide. Okay, so who am I? My name is Marco Bungart. In a former life, I studied bioinformatics and computer science in Jena, Germany. Then I was a PhD student in Kassel for 5 years, and since 2018, I am a software engineer at ConSol. If you want to reach out to me, GitHub, Bitbucket, Stack Overflow, whenever you see this handle Turing85 combined with this little penguin right here, chances are that's me. So if you want to contact me, just look for Turing85 and the penguin, and you are able to contact me. Besides Quarkus, my main focus is on Keycloak and GraalVM. GraalVM is more or less natural when you're talking about Quarkus. Keycloak is a hobby of mine, or an interest of mine for application security and single site login. So that's this for my introduction, and we are going to jump right into Quarkus. Why do we want to use Quarkus? Quarkus itself describes it as a Kubernetes native Java stack tailored for OpenJDK hotspots. And we will take a look at the poll in a second. Let me move this right here. It's relatively lightweight in comparison to alternatives, for example, Spring Boot or Pajara. Similar to Spring Boot, the application server is embedded into Quarkus. We don't need a separate application server, and it has a slim memory footprint. When we go native with Quarkus, so we can compile our applications from Quarkus down to binaries with the help of GraalVM. We get an even lower footprint, but that's good if you want to deploy into a cloud and you want to manage your resources properly. So you get the most bang for your buck, the most utilization on your cluster. And one thing we should note, that's something that some people notice quite late on, the instance performance or the program performance for native compiled applications is in general a little bit worse than on hotspot mode, so running on the JVM, but the overall throughput is higher. So keep this in mind when you're talking about Quarkus, and normally you're up and running with Quarkus within minutes. So we have a nice site called code.quarkus.io. Let me show it to you. Everybody who's familiar with Spring Initializer might recognize this. So you can click and you can pre-configure your configuration, download it, and start programming right out of the gate. At this part. And one important factor for Quarkus is developer joy. That's one of the most important pillars for Quarkus. So Quarkus aims to make your developing experience as enjoyable as possible. Yeah, if you have seen my last talk on the Quarkus dev mode, I think you know what I'm talking about. So you have a tight feedback loop for development, testing, and Quarkus is this core concept of Quarkus in developer joy is boosted as much as possible. At the beginning, when Quarkus started back in 2019, Quarkus had just a very small curated list of dependencies called best of breed. In the meantime, since 2019, the dependencies have broadened. So you find dependencies for almost everything you are going to need. For example, if you want to use templatization like similar to Thymeleaf with internationalization, we have Quote for this. We have templating languages for this. We have adapters for AWS services, for cloud services. So you are not limited in what you can use, and also you are not forced to use the Quarkus dependencies. You can also use all dependencies as you would in a normal JDK or normal Maven project. Plus, our app will restart within milliseconds. So that's that part to Quarkus. Let's take a first look at the poll. So we asked you what technologies do you use, and most of you said Spring, Java EE. A very large portion use Quarkus, which is awesome, and some people use other technologies. Okay, that's an interesting crowd. I'm doing these polls for quite some time now, and the part of developers using Quarkus is steadily growing. It's something I enjoy seeing. Before we start with the actual talk, if you have any questions, you have the possibility to use the Q&A feature. I would highly recommend you using it. Niklas will have an eye of the Q&A feature on the Q&A section, and will interrupt me when you have questions so we can answer them. So let's start with messaging. Normally we use messaging in loosely coupled systems. So if we have two services or more servers that we want to loosely couple, messaging is a great idea, but please keep always in mind that if you don't want loose coupling, in particular, if you need strong coupling, if you need, for example, a request response system, maybe messaging is not the right way to go. Yeah, there are always possibilities, for example, in JMS to have request reply channels, but this is not entirely how the system was designed. So normally, if you want to use messaging, make sure you're using loosely coupled systems, or your systems are loosely coupled. Okay, how does Quarkus implement this messaging system? Quarkus itself relies on the microprofile standard. I just saw earlier that one of you is joining from Jakarta, and Jakarta is, if you want to say, somewhat of a granddaddy of microprofile. So Jakarta is the name for Java EE, Jakarta EE, and microprofile is another layer on top, defining more services, more functionality on top of Java EE. That's why it's awesome that we have a lot of Java EE developers right here, because even if you don't know anything about Quarkus, you know Java EE, and Quarkus in its core is Java EE, so you can transfer your knowledge, which is awesome. Okay, in microprofile, messaging is implemented as asynchronous and reactive communication. And with microprofile, it's quite easy to swap out between different message providers. For example, if I decide I don't want to use a JMS, I want to use Kafka, then this is mostly configuration change. A little bit of programming has to be done, but it's quite minimal. We will see that in the code section coming up. We have support for JMS AMQP and Kafka when we are talking about microprofile. Of course, Quarkus has also vendor-specific implementations, for example, for Cupid or Artemis. This allows us more fine-grained controls, because we determine that we are going to speak, for example, to an Artemis server, and we can use the full functional feature set of Artemis. If we are going over the broader standards, for example, AMQP or Kafka, we are a little bit limited in the configurations we can make, but we get the flexibility to swap out the provider as we need it. So what are we going to look at today? We are going to look at a microprofile-based implementation. We are going to use ArtemisMQ and Kafka as our messaging providers. And we are going to implement communication between two services, customer servers and an order service. We'll look at them in a minute. And we are going to talk a little bit about observability. So how can I make the communication between these two services that are loosely coupled through a messaging system, how can I make this visible? That's an awesome feature in Quarkus that we can implement this. What we are not going to look at today are vendor-specific implementations. So we are not going to look at, for example, Cupid or ArtemisMQ as a direct client. We are just talking to Artemis as through the microprofile standard. We are not going to talk about Kafka streams, sadly. Kafka Streams has a different use case than Kafka on its own. Plus Kafka Streams is a whole nother topic that's quite complex, and I think it wouldn't fit in the time box we have for today. We are not going to have a demo on the cluster today, but if you want to use or try using a cluster, why not try the IBM Cloud? Right now, when you are registering yourself and giving your credit card information to IBM, you will get, I think, 200 credits for free, so $200 worth of cluster cloud usage for free. And just try it out, and maybe you can reproduce what I'm doing on the cluster. Maybe you want to deploy a little bit of a better setup, for example, with an Istio service mesh and so on. Okay, so what's the architecture of our system? We are going to have two services, a customer service and a user service, order service. And our goal is whenever a customer is created, we want to publish a message to a queue that this customer was created. And the order service should receive this message so it can create locally a shallow copy or slim copy, we'll see that in a minute, of this customer, and vice versa. On the order side, if we if we create a new order, we want to send a message, order summary back to the customer service over in the messaging system. The idea here is we can only start adding orders when we already have customers. So an order is always coupled to a customer. And on the customer side, we can have something like an overview, what orders did the customer make in the last, for example, 12 months or so. The customer messages are going to use AMQP with Artemis. And for the order service, we are going to use Kafka. So if you want to join along, maybe the internet quality on your side is bad, or my slides are not showing up or showing on your screen properly. Everything you're going to see, including the slides, is on GitHub. So you can click this link. Let me post this link also in the chat for you right here. Plus the commit messages are meant as a step-by-step guide. So if you want to understand what I'm doing and you don't have the time to listen to the whole talk, or maybe you're watching it on YouTube, or you just want to look at the code, go to the commit messages, take a look what I'm doing in the commits. The commits are quite small, and you should be able to follow along. So let's pray to the demo gods, and let's get started with our little application. So right now, I'm having both services running, but we don't have messaging. So we have here our customer service, for example. We can create new customers, we can get all customers, and so on. But the customer service in and of itself is not yet ready to publish messages to the customer queue or to the customer messaging system. And we have, as of now, no possibility to create new orders, at least not in the customer service, because the order service on the other side is able to create the orders in its system. But again, we are not publishing anything. So if an order is created, it's only created in the order service, not in the customer service. For the customer, it's only created on the customer service, not on the order side. For the services and what needs to happen when an order arrives, that's already implemented. We are just going to look, what do I have to do to get the messages going? So what do I have to do so that the customer service is sending out messages with every post request? What do I have to do to receive those messages on the order side? And the first line of business, at least for me, I like to move my dependencies in a local deployment folder, so I can have it in a Docker Compose file. Right now, we only have a database. The first order of business, when I go forward one commit, is to actually add our JMS system, in this case Artemis, to our Docker Compose. Yeah, I started this beforehand, so in my setup locally, everything is already running. But we see here we are adding the Artemis server. We are defining its ports, username and login. And next order of business is to actually get going with the implementation. For this, we add a little code snippet in the POM XML. So let me take a look. That's this part right here. Here we say we want to use the Quarkus implementation of reactive messaging for AMQP. Yeah, that's all we have to do. This already sets up our dependencies. Nothing else is needed. Next step is we have to actually configure the connectivity from our service to our message broker. This is done through the configuration file. We start by modifying the customer first, because the customer is the sending side, and I like to implement my stuff as the messages are going. So first, I like to implement the sending side, then I'm going to implement the receiving side. So if we take a look right here in our resources, application.yaml, we see up here, we have the setup for our AMQP host. For me, it's running on localhost port 5672, and username and password is Artemis. If you take a look back at the Docker Compose file, you see 5672 is exactly this port right here. And those are the credentials. We find them again right here in the configuration. Next step is this sets up the connection, but we also need a queue where we can send messages to. For this, we have this section down here, microprofile messaging outgoing, since the customer service is going to send out some customers to this queue. The next layer here is a name you can choose arbitrarily. You should choose in a semantic, meaningful way. For me, it's JMS new customer channel. We are going to want to use the small y AMQP connector. Remember back, that is what we added right here. Small y AMQP, this connector we are using, the driver we are using. We want a durable queue, so when a service goes down and cannot receive messages, or has only partially received some messages, then it should re-receive, another service online should re-receive them. And we do not want to use an anonymous sender. We want to register with username and password, and the service itself should also be registered with a name. So that's the configuration side, and that's really all everything we have to do to configure the connection to the service. Next part is, let's take a quick look at the customer service. Yeah, we can see here, we create a customer. From here, when we have saved the customer to the database, we want to send out the message. This means we need some kind of service layer or something that we can call, so that we send out the actual message to the JMS provider or the AMQP provider. That is what in microfile is called an emitter. And when I show you the emitter, it's quite simple. We have one class, that's this class right here, new customer emitter. We are going to implement a emit message, emit method that gets a customer response that we want to send out to the queue. Internally, we are using this emitter right here. That's an implementation coming from microprofile, as you can see right here. And through the constructor injection, we are binding this emitter that gets injected right here to this channel right here. Yeah. Again, think back to the configuration we just made in our application.yaml. That's exactly what we have written here. So this configuration takes effect for exactly this emitter sending messages. And that is what we are going to use to send the messages. And the emitting is then quite simple. we just call emitter.send. Nice thing about this is running asynchronously. So this send call doesn't wait for the message being sent, but it sends it asynchronously in the background. So our call in the service layer, right here, will return immediately. Yeah, we are non-blocking on this part. So
where is the call to the emitter?
Not yet implemented. That is
okay.
the next step. Yeah, we just prepared the emitter right now. And the next step is, okay, we have prepared the emitter. And now we have to call the emitter. And that's everything we have to do is just inject the emitter right here. Yeah, and then call it. That's everything we have to do to start sending out messages. Yeah. So we see this is quite not trivial, but it's relatively easy. And we have almost nothing, at least in our implementation right here, that gives you a hint that we are sending through JMS or AMQP. Yeah, we could be sending this stuff also to a Kafka cluster. In this concrete scenario, all we would have to change to send our messages to a Kafka cluster is to swap the connector right here, plus a little bit that we are going to look at in a few minutes. So, Niklas, do we already have some questions, or is everything silent so far?
Right now, looks like we will continue.
Awesome. So we just implemented the sending side. So our customer service would be able to send messages out to the order service. Next step, of course, is implement the receiving side on the order service end. Again, first order of business is we have to configure our connection. And this is quite similar to the configuration we have seen on the customer side. Again, we are setting up the connection, same host, same host, same username. And almost the identical configuration down here, just that we changed outgoing to incoming. So now we are saying, no, we don't want to have an outgoing topic. We want to have an incoming topic. We want to read from this topic. Yeah, same name. So this setting here is the end receiving the messages or the end outputting the messages. In the customer service, we had outgoing. So this is the end receiving the messages. Those two configurations, quote unquote, glue the two parts together. Yeah, they are listening on the same channel. And so what is produced in the customer service will end up on the order service. So now that we have configured our connection, we have to configure the receiving part. Yeah, right about now, we just have configured the connection, but we are not yet using it to receive events in terms of microprofile. We need what is shown here, a service that is annotated with add incoming. Yeah, and the add incoming right here, you see again, this is the channel name we have defined in the configuration file in the application.yaml. We don't need an emitter or a receiver or something like this. This will be handled automatically through microprofile. Yeah, so this message will be called for every message received on this topic or channel, and this code will be executed. Yeah, little bit to the message bit right here. The system would also work when I just receive a create customer request. We will see in a few minutes when we talk about visibility why I chose to use the message. The message here, right here, is a meta object. Whoops, is a meta object from microprofile, which wraps the actual message content in a meta object in this message object, so I can access, for example, header files, meta information, and so on. We'll see why this is relevant in a second. And we also see here when we receive the message, aside from the log message, we are going to call customer service.create new customer. So that means with these two parts, we already have our one direction from the customer service to the order service ready, and should try it out. For this, I'm going to start both services through Quarkus dev. Plug in Quarkus dev. So both services are starting. While the services are starting, I'm going to show you that I have nothing up my sleeve. I'm going to show you, for one, the customer database on the customer side. That's what should be opening right now. Yeah. Come on. It's empty. And I will also show you the customer database on the order side. And again, we see it's empty. So both services don't know anything about any users. And what we are going to do in a second, when both services have started, so the customer service, the order service has started already, customer service as well. I am going to send a post message to the customer service running on port 8080. And if everything goes well, we get a response right here. Okay, the customer was created. Let us fetch all customers and see, okay, the user service, the customer service knows this customer now. The more interesting bit, however, is if we look at the log messages, we see down here, sending new customer, blah, blah, blah. So our customer service has sent out the customer message. And when we switch to the order service, we should see received customer, blah, blah, blah. So when I now take a look at the database again, for the customer service side, okay, customer is in the database. And for the order service side, we see customers also in the database. So we have our first messaging track from the customer service to the order service implemented, up and running via Artemis and AMQP. And the next step is, okay, we have now a possibility to transfer our customers to our order service. The next step is when an order is created in the order service, we want to receive this order on the customer service as well. Again, first order of business is to update our local deployment. So we have a Kafka up and running. We see right here, Kafka is divided into two parts. We have, for one, the zookeeper part. There's the instance or the layer managing different Kafka, multiple Kafka hosts. And then the Kafka part, so that is where the hosts are actually running. Zookeeper is necessary to, so the different Kafka, the multiple Kafka deployments know of each other, so they can cluster properly. And the Kafka part is then the actually part sending and receiving the messages. That's what we are adding to our local deployment right here. Then we need some kind of client implementation to start using Kafka. That's what we have added right here. And you can see when you take a look at the difference between the AMQP and Kafka dependency, they are quite similar. Yeah, and we will see this again when we are now start looking at the implementation. As I said before, I like to implement the messaging in the way the messages are flowing. So I'm going to start by the order side, implementing sending of messages, and then finalize on the customer side where we receive the messages. We go forward one commit to the configuration of the order service. And we see indeed that we now also have a Kafka Bootstrap server. Yeah, that, if I'm not mistaken, should be the exactly the Kafka implementation, so the Kafka pod. And down here, we are going to use an outgoing topic. Yeah, since the order service wants to send orders to the customer service, we are going to call this Kafka new order channel. And the implementation is quite similar, but not entirely identical. We are going to take a look at this part in the next commit when we actually implement the emitter, so the part sending out the messages. I kept this analogous to the JMS implementation. So we have a Kafka outgoing part, and we have our emitter right here. Oh, I see there's something missing. Let's see when the second part is going to pop up. Same deal as before. We inject our channel. We say that we want an order response emitter, and we are going to implement the emit message right here, use the emit message right here to send out the messages over the send action. What I would like to show you, I'm not quite sure where the class ended up, is this part. Excuse me, that's correct. You see down here that we have a serializer defined. If you want to send JSON formatted messages via Kafka, you need to set this serializer right here so that the messages are actually sent via in JSON format. That's the part that actually takes right here when we are sending the message, takes this object, makes a JSON from this object, and then sends this JSON out object over Kafka. There are other ways to other methods formats to send these objects. I think I just forgot the name of the one. There's one, I think, from Google that minimizes the object. This would also be defined right here. So this is a part that's necessary for Kafka to work properly when you want to send more than just text messages. And this already is the sending side. Yeah. What we have to do again is we have the sending side implemented, but we do not call it in the service layer yet. Yeah, you see right here, we are creating the service, but we are not sending it out to the message channel. If we go forward one commit again, we inject our emitter, and now we are sending out the messages via the message channel. That's all already on the sending side. So let's go up one layer to the receiving side. Again, we are going to start with the configuration. Source, main, resources, application. And down here, we see we have an incoming channel of Kafka new order. Yeah, again, those two channels are defined with the same name, Kafka new order channel, Kafka new order channel, which glues, quote unquote, glues them together. And down here we see a deserializer. I will talk about this one in a second. Yeah, this here is only a setup. Now we are going to look at the implementation, since this is quite interesting. Again, implemented in the same way we did the sending and receiving for JMS. So implementation shouldn't really be shocking. We just receive a request right here, we log it, we create it, and in case there's an error, we are going to log the error. What you also see is this deserializer right here. On the sending side, we had configured a default serializer to serialize any old Java object into JSON. For deserialization, since we want to have tape safety, and since microprofile enforces tape safety, we have to add the type to the deserializer, and this means we have to implement the deserializer ourselves. Implementing it ourselves just means we have to extend from a certain object, a certain class, in this case the object mapper deserializer, and type it with what we want to receive, in this case a create order request, The actual implementation is then only a supercall with the class we want to receive. But if you forget to implement this part right here, you may get funny exceptions or no methods at all. So keep this in mind when you're using Kafka. You have always to implement the deserializer, and maybe, depending on what format you are using, also the serializer. So that's our communication from the order service back to the customer service. So let me stop the running services and restart them. First, the customer service. Niklas, again, the question, do we have anything in the QA section?
Nothing right now. Feel free to submit your questions.
Okay. You might be wondering why I stop and restart the services manually. When you're normally, if you use Quarkus Dev, you can just submit a request, and the request will be the service will be recompiled on the next request. For the sending side, this is working. For the receiving side, unfortunately, Quarkus is not able to recognize, oh, I'm receiving a message right now. I have to recompile and to hot reload. That's not working. This is the reason why I'm manually restarting, manually stopping and restarting the services right now. Just something you should keep in mind when you are working with messaging in Quarkus and are used to using dev mode. So on startup, we see already that something has changed, and here we see the configuration for Kafka. That means in this case, our customer service was able to pick up the Kafka cluster and was able to connect. And we have a similar output on the order side of things. Exactly, right here. What I'm going to do now is show you the order databases, first of the customer. We see no orders here, and the order database of the order service, and we see no orders right here. And now we are going to resubmit a new order with this UUID, this comment, and we are going to say the customer that is giving this order is Alice at Wonderland. That was the first customer we created. So let's send this out. Okay. Now we should see that the order service tells us down here, sending newly created order. That's awesome. And we also see on the customer side of things, receiving newly created order. In return, when I now query the order database, or the database of the order service, I see the order. And also when I query the order database of the customer service, I see the order as well. Okay, that's awesome. And now we could do stuff like, okay, customer service, please show me all orders of the of user Alice at Wonderland. And I get a quick summary of the order. I don't get anything, everything. For example, you might be seeing that the order description is missing right here. If I would like to have the order description, I would have to query the order service, because when I'm querying the orders right here, we see, okay, here's a description of order 66. Okay, that's what
we have our first question.
Ah, awesome. Yeah.
And right now you show a round trip through the system and say we create a customer on the customer service and it will emit a message to the order service. So now the question is round about error handling. Imagine the customer creation on the customer service works, it emits a message, the order service receives the message that we have a new customer, and now the creation of the customer and the order service fails.
There are different ways to approach this topic. The most common one is, let me show it right here. there are, let's first assume that the error is temporary. Yeah, so you you have the suspicion that when you resubmit the error, you can recover from the state. Yeah. In this case, we can. That's the wrong side. We have to go to the receiving side, the sending side. Source main Java boundary messaging JMS incoming. You see right here that I'm actively echoing the message. Yeah, this call to message.eck leads to the message being quote unquote removed from the queue. If for some reason this part right here would fail, I wouldn't come to the message.eck. That means another service would pick up the message in the future and retry it. This would be one scenario we could go down. The other thing is maybe you retry and retry and retry, and you cannot create the customer in the other service for whatever reason. What we are normally doing then is move this message to another queue, the so-called dead letter queue, and this should always be inspected by either an automatic process that picks up, hey, here's something in the dead letter queue, please take a look, or should be inspected by a human. So those two approaches are two possibilities how we could do error handling with this part. What is a little bit more challenging is if you would like to say, okay, creating the customer in the order service failed, I want to undo the creation in the in the customer service. That's a little bit more complex and would require most probably either a REST call or another messaging system. But that's also an architectonical part you would have to decide on, since normally you try to divide the business logic into so-called sagas, and each saga should be rollbackable in itself. So the creation of the customer in the customer service and the creation of the customer in the user service would be two sagas. And you not necessarily want to roll back the creation of the customer in the customer service when the creation in the user service failed. Does this answer your question?
Let's say yes. And if it does not answer the question to the Marwan, tell us, and we will talk about this later. Okay.
Okay, awesome. So last thing I would like to talk about is observability. We have implemented a loosely coupled system. Okay, everything is awesome, but loosely coupled systems normally come at the cost that it's hard to understand what they're actually doing. So if a customer is created and I'm just looking at the system, I don't know necessarily that the message is received by the order service and the order service is doing something. We can make this actually visible. There's an awesome tool called Jaeger. And in terms of, that was wrong tab. In terms of Quarkus, this is implemented through something called not OpenTelemetry. OpenTelemetry is the new name. Let me check it out right here. Yeah, here, Open Tracing. Yeah, Open Tracing is the quote-unquote old library. The Quarkus team is in the process of implementing a new library called OpenTelemetry. As far as I know, it's still in beta, so we are using Open Tracing. What we can do with this is make normally only REST calls, but in our case also the calls to the queue visible. We are going to add the Kafka client so we can make the Kafka calls visible. And we get the JMS client for free. So the JMS implementation is already there. I will skip a little bit forward since we are running low on time. Let me show you the configuration quickly. That's nothing too spectacular. Source main resources, and I hope exactly Jaeger configuration is defined right here. So you just say, where is the Jaeger located? How do you want to sample? Plus what we are going to do right now is we need to implement Jaeger context propagation. I will skip this part for now. For the JMS part, basically you have to show Jaeger how you can correlate the REST call with the actual sending of the message. I will leave that up to you to look into the code. A little bit more interesting is the configuration for the where are you? Exactly here you should be. A little bit more interesting is the configuration for the Kafka service, since we have to swap out the we have to define an interceptor class. That's this one right here. This tells Kafka that, hey, if you're going to send out messages, please intercept the messages with this class, and this class will do all the Jaeger and magic and will make it so that we see the messages in Jaeger. Same thing on the customer side, but on the customer side, we have to actually implement a little bit less or more. Let me take a look. Okay, here we have implemented this part right here. That's the tracing consumer interceptor, and that's the tracing consumer interceptor exactly. So, and when we are going to restart these services right now, we should be able to see plugins def plugins Quarkus def. So give the system a second to start up. I'm going to prepare my Jaeger website. That is right here. Yeah, right about now, Jaeger only knows itself, so we see only the Jaeger query. But when the services are started up, we are going to create a new customer, one new customer and one new order. Bob at builder there, Bob builder. So you are not yet ready, and we are going to create an order for Bob at builder order 67. Make sure I didn't have any typos. That's looking good. So we are now going to create a new customer Bob at builder. That did work, and we are going to create a new order for Bob at builder. Now we are going to take a look at Jaeger. Okay, we already see we have 3 services now. Let's start with the customer service and show the traces. And right here, that was the first post we made. Yeah, we see, okay, we had a post call on the customer service. This led to a message sent on the JMS queue right here. Yeah, and we already see here, this is the customer side. Customer side finished processing, and then down the line over here, we had the order side receiving this message. So we can make this asynchronous decoupled communication visible through, in this case, Jaeger. Same thing with the order service. When we take a look at the order service, we see down here, we received a post request on the, that's the wrong one. I want you. We received a post request on the order service that led to a message being sent on the Kafka topic. Again, this is the order side ending right here. And down the line over here, we see that the customer service took action and received the message. So not only have we loosely coupled systems, we also have the communication between the systems visible, and we can even see this hopefully when we say I want to see my system architecture. Oh, that does not work. Maybe it does. Here, trace graph. Exactly. Here we can see the flow of the information through the different steps. Highlighted in colors are the different systems. So yellow is the order system, blue, green, blue-greenish is the customer system. And with this, I'm at the end of my talk. Are there any questions so far? Niklas?
No new questions right now, but I think we can wait maybe a minute that you can think about some questions and then submit them.
No questions? No questions so far. So if there aren't any questions, then I would like to thank you for your attention. And I hope you learned something. I hope I could give you a quick start to using messaging in Quarkus. And again, thank you for your attention.